are you? Having a great time? Yeah. Woo! Great time to be here. I came all the way from Tel Aviv, from Israel, only for this talk. So very excited. Thank you very much for having me. So, got a question for you guys. Does anyone love yoga? Yeah? Cool. Dancing, maybe? Because no, what do you do for fun then? Part of Android. What do you guys do for fun? Why are you so programming? That's it. Okay. So I've been practicing yoga for quite a few years, actually. And a few years ago, I started taking a teacher's course. And my teacher, my amazing teacher, Simon, told me something that I really love. That one of the things about a yoga flow or a dance, for example, that it's like a caress. So the fact that we love it so much is because it's like a continuous thing and a very smooth thing. And when it starts being like all jittery, we hate it so bad. And it feels so wrong. And it's kind of the same thing about apps. So today we're going to talk about how to get your app to be so smooth. In order to understand that and how can we accomplish that, we need to take a little look under the hood to understand a little how the system works. So I'm going to tell you some stuff about that, and then we can see how can we as developer improve our app maybe, after we can understand how things are working. So a little bit about myself. I'm Britt Barak. I'm an Android developer. I've been leading a few teams already in Israel, now on a stealth mode startup, so I can't share so much information about that. Also, I'm co-leading Android Academy TLV, which is, one of the largest and most active Android communities actually out there. We have many courses for beginners, for professional, for designers and developers together. All voluntarily. Encourage you to join us on our Facebook group for more discussions and stuff like that. Also leading Women Tech Makers community in Israel. So if you ever come by to visit me in Israel, I'll be super happy, and I have so many events and meetups to invite you to. So I'll be happy to see you there. Anyways, enough about me. Our story today is about love and about lies and about deceit. It's about a very, very, very handsome fellow named the CPU. And the CPU has an object he inherited, a very special object, and his whole task, his whole purpose in life is to go and find his love, the wonderful display, and have his object painted on her. Okay? That's the story. I know that it sounds kind of familiar for you because this story is not unique for Android. It's also on many different platforms and folklores, so it has kind of name. It is called Rasterization. Rasterization is exactly that, taking a high-level object that, well, we as developers, as humans, can understand, and have it displayed on the screen, some kind of a screen. That's the story. Well, this can take a lot of time, right? Sounds like a difficult thing to do. It can take a lot of time, and the CPU doesn't have his whole lifetime to do that, to find his display and to have the object painted there. So we need to do it very fast. He needs some kind of a superpower or superhero to help him. So he went searching, and luckily for him, he found the lovely GPU. So the GPU is the graphic processing unit. She's very, very good. She's best friends with the display. And she's very, very good at taking polygons and textures and have them display on the screen. Really amazing at that. She does that very, very fast. She tells the CPU, no worries, just get me the polygons. I'll display it on the screen, no worries. So CPU is super happy. He goes home, but then he says, wait, I don't know any polygons and textures. I know objects, so what can I do? Like, how do I resolve that? So he goes and asks his friends, and luckily, he has one friend with an API, which is a very important thing. My mom always told me, have one friend who is a doctor and one friend who is an API. So CPU has a friend who is an API. His name is OpenGLES, and he tells him, dude, don't worry. You just explain what you want to do. Just tell me, give me instructions to how do you want your object to display. And I'll talk to the GPU and I'll make the polygons out of it. Don't worry at all. So the CPU, who has an object, would prepare a display list, instructions, would give it with the OpenGLES, would give it to the GPU. The GPU would receive it as polygons, and it would display it on the screen. OK, good. We won. So that's it, I guess. You can go home. No, I'm joking. So let's dive in a little bit deeper to see exactly what needs to happen there. Hopefully, you guys know that this whole process needs to take how much time? 16 milliseconds. We have 16 milliseconds to do all these things in order to have a smooth experience. We can talk about that maybe later on why it is like that, but now let's take it like that. So let's see what needs to happen within the 16 milliseconds. So first thing we want to do is to understand like exactly what kind of object are we talking about in terms of like how much work should it be for us. So first thing, we want to measure it and to understand its size, right? Later on, after we know the size, we want to see if it can even fit the screen, or to understand the position of the view, where to place it, where to position the view at the end on the screen. Great. After that, what's left? To draw, to understand how we want this object to be drawn on the screen. So we make the display list that we talked about before. What do we need to do now? I want to hear you guys. What do you think we need to do? We're finished? Yeah, we need to give it to the GPU with the OpenGL. So we upload the display list as polygons and textures to the OpenGL, to the GPU, and then GPU takes it and presents it on the screen. So far, so good. So we want to execute it. We call it an execute, just to execute the display list so it can be displayed. Amazing. Now, one small thing. So we said that every 16 milliseconds, we need to show a frame on the screen, right? So by the way it does that, the way the GPU does that, is just line after a line from the top to the bottom. For some reason, it doesn't really matter right now what is the reason and why does this happen, but sometimes it can take a longer time to process this a certain frame, all right? So, well, if, for example, we have a frame now with a pink frame on the screen, and we want to process another frame, a purple frame, and we start processing it from the top to the bottom, and it takes some time. So after 16 milliseconds, if we didn't finish that, if we didn't finish the process, we're going to see something like that. We have the pink one before, and then we're going to see just half of the purple one because we didn't finish it in 16 milliseconds. And this doesn't make any sense, because what's going to happen, the frame going to show us something like that maybe. And now my yoga posture, do you see the leg? It is not so stable right now, and it doesn't make any sense to see this kind of picture. So instead of that, instead of just executing and displaying the frame on the screen, what we're going to do is to use two buffers. So we're going to use a back buffer to process the next frame, and we're going to have a frame buffer that is what we're going to display on the screen, right? And this time it's going to make more sense. So right now the frame buffer is the pink buffer, and this is actually what we see on the display on the screen. And if we start processing the purple one, it's going to first be processed on the back buffer. Even though we didn't finish it yet, after 16 milliseconds, we're going to show only what's on the frame buffer. So this is what we're going to see on the display. And only after it finished, the back buffer is going to be all purple, and then we can switch the buffers. So the frame buffer becomes the purple one, and then we're ready to show it on the display. So it is true that we saw the pink one, the pink frame, more time than we expected, and it kind of gave us like a jittery experience, but at least it makes sense, right? The picture at least makes sense. So this process of having the frames sync together is called Vsync, vertical synchronization. So this is also something we need to do in the process of having a view becoming a pixel. So right now, this is the steps that we know of. We finished the Vsync part, and then we have a measure and the layout part. Then we're going to draw the thing. We're going to sync and upload it to the GPU, and then to execute and switch the buffers. OK. Now, this process, as I told you so far, it relates to a view that we just want to present it as is. But we also have on our app lots of interactions with the users, right? We have lots of widgets that we create interaction with them, like buttons, like text views, like added text, stuff like that. And as the users are the most important thing for us, when the user does something, that's the first thing we need to handle, right? So if the user clicks on a button, for example, all the callbacks that you wrote, all the on clicks and everything that you wrote on the callbacks, on the text watchers, all of those stuff are the first thing we need to handle before the measure, before everything. So we're going to do that. And later on, many times, an input event causes an animation, right? Because if we click on something, we need to have the user understand that something has happened. So in many times, it can be like a ripple effect, or just changing the colors, or making something bigger or smaller. So it can be like very subtle, but this is an animation that we want to have the users to see. So after the input event, we're gonna process all the animation callbacks. First reason is because we want the users to have the feeling that we're treating with respect whatever they are trying to do. Second reason is because that many times after the animation, we're going to have the view changes its features, right? Like it's going to change its size, it's going to change its location. So the measure and the layout phases that we talked about before are going to be changed. So it makes sense to do all the animation processing before the measure and the layout that we saw before. So process is something like that. I just added the input and the animation before the measure and the layout, and these are the phases that are going to happen. When something is changed, like in the animation, under the hood, we have two options to notify the system that these things need to change, that we need to change the view. One method called invalidate, which means the draw part, please do it again. All right, the sizes are the same, the locations are the same, just draw the view, just draw it again. Make the display list a new one, or update the display list, but just do this part. Another option is if something changed like heavily, like the positions or the sizes, and then we want to measure and lay out everything again, and then we use the request layout. So this method usually are called under the hood, but you can also call them yourself, right? If you make your own animations or your own views. So if you call yourself many times, like 10 times, on a frame, you do invalidate, invalidate, invalidate. Do you think that what we're going to make 10 times the display list? No, it doesn't make much sense. So what I want you to know and to be sure that of two things. First, the steps that we talked about, the phases, are going to be in order. On that order, you can be certain of that. Second thing is that a step can be called only once at a frame. All right, we have a guy named the choreographer, and he's in charge of these two things. So what he does when there is an invalidation or a request layout, there's just a flag that he's in charge of. It's just a flag, and so it's going to tell the view, next time, next frame, do this phase. Next time, do the draw part. Next time, do the measure part. So it's just a matter of flags. I think you know the choreographer maybe because he yelled at you once or twice on the logcat that you skipped this and this frames, because that's his job. He's in charge of that, and in charge to make sure that everything happens on time and in order. All right. This is a part of the code that happens when you do when the choreographer prepares the frame. So he has this callbacks for the phases, the steps that we talked about before, and he's in charge of them to do that in order, so you can be relaxed and that this is going to happen for you. So now there are 3 steps that I do want us to dive in a little deeper so we can understand as developers what we can do to make them better. These are the phases. All of them happen on the CPU. And these are the phases that we as developers have more, we can impact on them. More than the other steps that we talked about before, so I just want us to understand them better. So first one is the measure one. The measure, we said, is about understanding the position of the view, right? Well, when I said the position of the view, of course, I also mean the position of the size. So the measure is about understanding the size of the view and its children, right? Because if I'm a linear layout, for example, my size includes the size of my children, so I have to understand those. The way it works is that we go all the way up the view hierarchy. So we ask the grandma, hey, what's your size? And she's gonna say, wait a second, I'm gonna ask my kid. So she's gonna ask the father, and the father is gonna ask his children, and this is how it goes. So you can understand from this explanation that the measure part, the measure step is, well, it can be heavy if you have many views there, because every time we're going to do a measurement, we're going to ask all the views. So sometimes the parent also have like the demands, right? I can tell him that what's the size you want, but you only have 100 pixels. All right, so you have the view's desire, and you also have the parent's demands. And this is how we assess the measurement, the sizes of the views. So we already said that it can take a long time, or it can be a heavier process because we have a pass on all the views. But I want you also to remember that it can happen more than once. Sometimes we have to measure all the views more than once. For example, if we have a linear layout, like we said, and we have weights, So we don't yet know the size of the children. So the parents is going to first ask, hey, kids, what are the size that you want to be? And then he's going to get the answers. He's going to evaluate how he want to, what sizes he can give them. And only then he's going to ask them again, what size do you want to be? But you have only 100 pixels. Okay, makes sense? Right. So a small thing I do want to talk about that sometimes when we develop our apps, when we develop, we try to use, I don't know, animations and stuff like that. We try to understand the size of the view. So then we say get width, get height, and we get 0. And like, I can see the screen, I can see the view. How come it's 0? It exists. So how come this happens? Well, so first thing I want you to know that the size of the view, the height and the width are, when we ask for width and height like that, it's the size that is gonna be drawn at the end of the process. Right? It's the size that that everyone agrees upon, and this is the thing that is going to be drawn at the end. All right. But we also have a measured width and a measured height, and this is what the view wants and hopes to have as a size. And this is going to be decided on the measure part. So it's even before the width and the height, we know the measured width and height. Okay, now second thing, what happens if during an animation or an input, I want to know the size of the view. So like we said, the animation and the input happens before the measure, before the layout. I don't know yet the size. What can I do then? We're going to use ViewTreeObserver, which is one class that we have per view hierarchy, so we never create it. It's not something we call new for. We use the getter for the view tree observer for a view hierarchy, and then we can attach some observers. We can attach listeners to this observer in order to know global changes on the view hierarchy. So for example, it can be focus change or a layout change, or before we started drawing, or after or during the draw. So these phases that we talked about before, we can attach listeners to. Thing is, just don't forget to release them. So if you add a listener, first thing you need to do is to remove it. This is kind of a thing to remember. So next step is the layout step. So the layout, like we said, is about understanding the position of the view. Where is it going to end up? It works kind of the same as the measure part. So once again, we go all the way up the view hierarchy, and just a view after a view, we understand and we try to assess the position. Once again, there can be more than one passes. For example, for the relative layout that we often use, it is always going to have two passes. Because one pass, every view is going to just say wherever they want to be. Next to this view, behind that view, everyone's going to say whatever they want. And only then, after everyone tells us whatever they want, the parent, the relative layout, is going to assess where and evaluate where can they actually be, actually give them a size with pixels at locations, and only then we can determine the final size, and we go a view after a view and tell them where do you want to be, this is your location. So on relative layout, there are definitely two passes, which is something we have to remember. linear layout with nested weights are going to behave quite the same, and also there are sometimes if we use grid layout, it's going to be happening also. This kind of process, when we do this pass through this layout phase a couple of times, it is called double layout taxation. This is something that happens quite a lot, and we need to remember and we need to take it into account. So usually, have to be honest with you, usually it works fine. Usually we can handle that. We use relative layout all the time and it works fine for us and it is okay. But sometimes when it's on the root or the view hierarchy is very, very, very big, or that we have a lot of them. For example, I got to work on an app that we had a view pager, and for each page there we had a relative layout. We had a recycler view, and each item there was a relative layout, and it was well, honestly, relatively complex and lots of nested views there. So, like you can imagine, we had a big performance problem, and it was very, very easy to see. So, first thing I did, because I understand that this is how it works, first thing I did before profiling anything, before having a complex evaluation of the stuff, I just understood that this is a view that if we have a problem with rendering this view, this item, it's going to be a big problem. So honestly, I just opened this XML and I could have seen that this is a problematic one, and I just flattened it as much as I could. Without profiling, without like any complex stuff, it did magic to the performance. So this is just something that if we know, we can have our apps work better. So flatten your hierarchy. Be aware of this kind of things, this kind of situation. Request layout. If you have your own animations or views, custom views that you do, and sometimes without even noticing, you call request layout. So now you know that the request layout is going to pass more than once, sometimes more than twice or 3 times on your view. So if you can just not call it, try to not call it. All right, a tool that I hope you know already. We don't have much time, so I'm not going to deep dive into the tools. But a tool that can help you understand how the view hierarchy goes on your app, called the view hierarchy. You can find it on the Android device monitor through the Android Studio, and you can actually see the hierarchy with, I don't think you see it, but you have some dots there with different colors that can tell you about the performance of the measure, the layout, and the draw of these views. So now you kind of know what's it about. So I told you about all these kind of crazy situations with layouts, with the different layouts, and it seems like that there are no winners. I mean, if I choose a simple layout, then if I have like a complex design, I need to do like lots of nested simple layouts there. And if I have a complex layout, like relative layout, for example, I told you that it's problematic if it's on the root view or if the view hierarchy is deep. So we have a problem there. So what should we do? I mean, sounds like there's something that should be smarter, right? So on IO 16, there was the constraint layout that was announced. Hopefully you guys had the chance to play around with it. Once again, I'm not going to deep dive into it and how to use it, but its whole point is to address this problem. So we have a layout, that is supposed to be very performant. Why? Because it's kind of like relative layout, that you have a lot of views, and you can define the connections and the constraint between them in a very complex way. Although it comes with a very user-friendly new layout editor, which I'm sure you've had the chance to see, because it's not only for Constraint Layout, but for all the layouts out there. We can use the new editor for, but specifically for Constraint Layout, it's a great help for us because the constraints between the views are so complex that we don't want to see the actual code most of the time, the actual XML, and it's very helpful to use more human way to see the views and the connection between them. So if you haven't played around with it yet, really encourage you to do that. It can help you with the performance a lot. So last part is the draw. The things that are like the most problematic when we talk about the draw part, I can say that there could be like two main problems. So one is if the on-draw is very, very heavy and takes a lot of time to draw the view. Mainly it happens when we have object allocations without even noticing. So when you have new object, new integer even, it's gonna happen once, the on-draw is gonna happen once in every 16 milliseconds. It's gonna do, like, you're gonna see it definitely on your view's performance. So if you have this kind of thing, just have it as fields, or just move it out of the on-draw, because it's gonna be very, very, you're gonna see it, definitely. Second thing is something that is called overdraw. Overdraw meaning if you draw a pixel and then you draw another pixel on it. So you spend like double the time to draw this specific pixel, and it can take too much time, and it can definitely show. The reasons for that usually is the background that we define, like we have a view on top of a view and we define a background for both of them. Many times it happens because we forget that the theme, we can define background on the theme. And then if we define another background on the XML, it's like it's one on top of the other. So this is kind of the things you want to notice. And I just want to show you that there is a tool that is very, very handy to detect this overdraw situations. On the debug tools, you can see the overdraw debug tool. It's gonna, once you allow it, it paints your app, the app you're seeing, in many, many colors. And the colors just, I don't know if you can see that on the monitor, but the colors just mean how much overdraw were there. So for each pixel, you now can know how many times did you paint over it. Once or twice or 3 times or 4 times. It just can help you detect that, and then you can go ahead and look at your app and see what's the reason for that and fix it. So this is about the overdraw. We don't have time to go deep into the tools, but I just want to mention a few of them. So we talked before a lot about the steps, and I gave you some colors to define them. And the reason for that is that you're going to see these steps and these colors in the profiling tools that are out there. The profiling tools, first of all, is the GPU profiling tool, and once again, it's a debug tool that you can allow on your phone and actually see this kind of graph with the colors that matches the colors of the steps that we saw before. It just gives you how much time did each step that we saw before took. There is a line there for the 16 millisecond benchmark. If you pass that, it means that you skipped frames. So that way it can show you a little bit of which step should you deep dive in and understand what's happening there. It gives you some more sense about them. There is I hope you saw it at GPU monitor. It's kind of the same on the Android Studio. It's kind of the same, and it got a lot better. Lately, the colors on the left-hand side, the colors on the monitor is the exact colors and the steps that we talked about before. So you can see those. Lastly, there is the Vitals dashboard. It's really new thing on the Play Store. I hope you guys got to know it. It gives you all kind of metrics about your app's performance, ANRs, crashes, lots of stuff, and also the frame rates and frame metrics. So there are a bunch of stuff that are being done for you, and you can see them by default on the Play Store, on the dashboard. But also, if you want to, you can have the, on your app, on your code, just use the window on frame metrics available listener, and there to have, like to grab metrics specifically for your needs. So I don't know if you can see that I just took the constants of the frame metrics. I just want to show you that these metrics that you can use and you can ask questions about through your code are exactly the steps that we talked about before. So hopefully now you know what they mean and a little bit how you can address them. These are the steps. Once again, hopefully it was helpful for you to understand a little bit what's going on under the hood. Honestly, we don't have so much time to talk about everything, as this is a very, you know, it's a lot of things. We can talk about a lot of things regarding the steps and the profiling tools. So this is all that we have for today. A little bit of what we did. We saw the process of how things are going on under the hood, of how from a view, an object that you as developer write, what's going on, and how does it become pixel on the screen. And then we saw some tools that can help you profile the situations on your app. That's all the time that we have for today. I have on Medium some posts that are pretty much notes for this lecture, so they can help you maybe remember the things that we talked about and maybe to explain them better. So check them out. And also, I'd love to keep in touch with you all. I'm here for later for questions and for thoughts and stuff like that, anything at all. So thank you so much, and I'll see you later.